It's probably becomes the same simple sum of the demand.
Yeah, I mean, the summer is just.
Whatever people, the worst summer they can remember.
Yeah, that's true. And last week we had 2 days of rain non-stop, and then it would rain for 2 months.
Is it a heat wave as well, or is it?
No.
I was just saying it's just constant rain.
Cold and wet.
I don't know which I prefer. It's been hot non-stop here.
I know what you're mean.
Yes,
Exactly.
It's raining. It's raining often. It's not raining heavily.
Right.
Usually, it's just raining for an hour.
Especially
Maybe that's out.
these light rain usually.
And this time it's just starting rain, and it didn't stop until, I don't know, after 3 days. There are floodings going on everywhere, and
No.
stop it.
I was wondering if you had
We're not using any umbrellas anymore.
They said they were.
The
Yeah.
horizontal wind should get the water.
US moisture in humidity exaggerating the effect of heat. What people in Britain well understand is the effect of moisture in making cold much more. Somebody pointed out in one of the talks yesterday, the heat capacity of water is about 1,000 times out of X. So, you've got cold water around here, it's chills you real fast.
People are not that happy right now with the Olympics going on and
Yeah.
whatever.
Try to be more professional than it was for the past 15 minutes. Still trying to be a little more professional than it was for the past 15 minutes. Swear not great.
Okay, right. Yeah. She will instruct us English.
Right.
Well, I grew up in Southern England, quarter stops.
I'm originally German. So
Yeah, right.
I don't know. I'll already get this injected, after 50 years and stuff like that.
Yeah.
It's not English, it's Scottish.
Right.
But it's- the separation is just important.
Mhm. Okay, well, looking at the clock, we actually have one speaker not here right now, but go with that. I'm sure I know he's here because he was at breakfast this morning, as probably were several of you. And so, first of all, welcome. This is always an interesting and varied session of student chapter representatives' presentations here. By way of introduction, for those of you that weren't there this morning, I'm Peter Turner, and my day job is as Dean of Arts and Sciences at Clarkson University, which is way upstate New York, almost in Canada. And also SIAM's Vice President for Education, which is why I'm chairing this session. And as several of you know, the growth of SIAM chapters, SIAM student chapters, has been extremely rapid over recent years. And as is also represented today, now over 20 of those student chapters, which is also close to, in fact, slightly over 20% of the student chapters are from outside of North America. So it's really is. The students are probably leading the way in the internationalizing of SIAM, which means, so you're representing and obviously you're representing the future of SIAM. All right, well, enough from me, and what I want to do is to let you guys do the talking, because there's not all that much time. And the first talk, as you can see, positivity preserving multi-step non-recovery methods, and it's going to be presented by Zack on the University of Massachusetts Dartmouth, and he will tell you about the other acknowledgements.
Alright, hey guys, I'm Zack Grant, like you just said. I work under advisors Zack Gottlieb from University of Massachusetts Dartmouth, and David Ketchison, who's actually at King Abdullah University of Science and Technology, which is in Duval, Saudi Arabia. Everyday scientists, you actually use ODEs and PDEs to do a lot of models of physical phenomena every day. A lot of these things, like maybe you're trying to measure the depth of water, or you're simulating sort of disease to a population, or even the density of a traffic, you're doing traffic simulation. A lot of these in the nature of the actual model you're using have certain requirements. For example, you really can't have negativity in your solution when you're trying to measure the population of something. So that's really the motivation of our talk, as we're going to look at, we'll start with the partial differential equation, like UT plus f of u sub x equals 0, which is the hyperbolic conservation law. And this is known to have a positive solution. So if you can design a special spatial discretization for f of u sub x, that if it's coupled with the forward Euler time-stepping method, it actually assures that your numerical solution will always be positive under some certain time step. It's really great now that you get to preserve this positivity, but the bad thing is forward Euler time-stepping is only first-order method. So the real question is there a way we can really keep this nice positivity property that forward Euler really gives you, but actually use a higher order time integration method instead of the forward Euler time step? That's really what we're focused on. So if we look at this, consider ODE system, which you'll just get if you discretize a PDE or a system of ODEs. And if you use your right spatial discretization, which ensures the positivity, you want your time stepping to ensure it as well. So if you can get a special spatial discretization so that UN plus the forward Euler time step satisfies the positivity requirement that UN plus 1 will always be greater than or equal to 0 as long as your initial solution UN is. And forward Euler does that as long as you satisfy some time step restriction that delta t is lesser than what we call delta t forward Euler. And this delta t forward Euler is actually not like some one delta t that satisfies for all problems. It's very distinctive to what spatial discretization you're using. This is set delta t you can use that will guarantee this positivity requirement. It's really experimental, but this is very important to the rest of the research because you'll see soon. So since forward Euler is really only first order, is there a way that we can actually get a higher order time discretization as well? So how can we ensure this positivity property also get really high order time integration methods? That's the goal out of this. So it's actually kind of like obvious, I guess, but really isn't at the same time. So if there's a way that we can actually decompose our higher order time stepping method into a convex combination of a bunch of forward Euler time steps, then since every forward Euler time step has the positivity solution, and then if you do the convex combination, so it guarantees that we're just multiplying by positive coefficients, we're pretty much doing the summation of positive coefficients to positive solutions, and it makes sense that